Open Systems Interconnection Model. The Open Systems Interconnection Model, or OSI model for short, is a 7-layer data model that very simply describes the software protocols and hardware involved in end-to-end network communication. At the top of the OSI stack, the application layer represents protocols such as HTTP for web browsing. End users interface their internet apps at this layer, and unlike network admins, are generally not concerned with lower layers. Also known as the payload, the data passing down the OSI stack undergoes what is called encapsulation, the process whereby each layer adds specific information to help move the payload across the network, closer to its final destination. After passing from Layer 7, Layer 6, and Layer 5, the payload arrives at Layer 4, the transport layer, where it is encapsulated with network protocol and port information. The resulting envelope of encapsulated data is called a segment. At Layer 3, the network layer, the segment becomes encapsulated with IP address information. The resulting envelope of encapsulated data is called a packet. At Layer 2, the data link layer, the packet becomes encapsulated with MAC address information. The resulting envelope of encapsulated data is called a frame. Finally, at Layer 1, the physical layer, the frame is converted to a modulated carrier signal, then transmitted over a physical medium, be it wired via copper or fiber lines, or wirelessly via radios. Across the network, APs, switches, and routers all help move the payload to its intended destination, examining info layer by layer in a process known as decapsulation. Here, the AP listens to a host's wirelessly transmitted signal to rebuild the encapsulated data, then determines at Layer 2 the intended local recipient is the gateway, and forwards along a rebuilt frame via Ethernet. Similarly, the gateway receives the wired transmitted signal, rebuilds the encapsulated data, determines at Layer 2 that it is the intended recipient, but discovers that the Layer 3 address actually belongs to a host on a different network segment, and forwards along the rebuilt frame via Ethernet. The process is repeated over and over until the payload reaches a network host who, at Layer 3, discovers that it is the intended recipient, and at Layer 4, that perhaps an established connection exists for the packet, so the end user can retrieve the payload in the respective application at Layer 7. At Layer 2, data moves between nodes according to MAC addresses. This is commonly understood as intranetwork communication or local segment communication, like when a host communicates over a Ubiquity AP or switch to reach another host, but also when data moves across direct links, like two peered internet routers linked at a data center, or a point-to-point Ubiquity radio link. At Layer 3, data moves between network hosts according to IP addresses. And at Layer 4, protocol and port assignment help hosts decide how to establish the connection, if necessary, on both sides. As a final networking note, the term packet broadly describes any network traffic, even when discussing the Layer 1 physical signal, Layer 2 frame, Layer 4 datagram, or Layer 7 data payload.